This is our, I believe, review part 2 for test 1 through 55. The year is 2021. It is March the 23rd. The hour is 2. The minute is 12. The second is 10, 11, 12, 13, 14. Probably won't keep going like that, though. All right. We're going to pick up with question number 15. This is a combination question. So whenever you go to plug this in your calculator, you're looking for math, probability, NCR. Okay? That's what we're going to use here. And not to say that there aren't other methods to use, but if you do what I'm telling you to do, basically what you're going to show me is how you've plugged it in your calculator. So what we want to start with on this is how many times our trial is taking place, which in our case is 3. So if you have a newer calculator, you can go math probability NCR and it will give you, it'll show you a box on either side of the N, or sorry, either side of the C, and you'll plug in the one on the left and then you'll plug in the one on the right. If you have an older calculator, which would look like, if I can find this one, like a TI-83, right? If you have one of these, which is like what you would see, I don't have one pulled up. All right, you're going to have to type in the 3 first, and then go math, probability, NCR, right? So that your 3 is left of the combination, and then you're going to, after you have that, you're going to have the number of times you wanted to do something specific, okay? In our case, it's 2. Okay, we wanted to do something specific twice. The next thing that we want is we want the probability of a success. Okay, what is the probability of flipping a coin and getting a tail? Yeah, it's 1/2, right? 1/2. Now, the exponent that we want is the number of times we want that success to happen. How many times do we want that success? How many times do we want tails to occur? 2. All right. Now, as odd as it seems, we need to have a failure, right? We have to have a certain number of fails, right? And in our case, that is still 1/2, because what we want it to hit heads once. We don't care when it hits heads, but it has to do it once out of 3 times. And so our exponent is the number of times we need it to fail. Okay, does that make sense? So if we plug this in our calculator, okay, we're going to get 3/8. Okay. Let's see, I want to test something here real quick. That would be what, 1/4 plus, nope, doesn't work like that. Okay, just making sure. Okay, 3/8. So what you might want to do is try plugging that in your calculator. Now, what it's going to actually do is when you plug it in and hit enter, it's going to tell you 0.375, but we're going to hit math, fraction, enter, and it's going to give me the 3/8 that we're looking for. And we want it as a fraction because it says what is the probability. Probability is not represented as a decimal, it's represented as a fraction. So all of that makes sense. Okay. All right. Let's hold on, we'll do this. Okay, we don't want that. We want 16. There he is. Okay, 16. What equation is the inverse of y equals 4x plus 5? There are 2 steps necessary to find the inverse of an equation. Those steps aren't hard, but if I ask you what is step 1, can anybody tell me? If I want to find the inverse of a function, what is step 1? You think you know? No. Nope. It's not as simple as just making y negative. No. No, that's the whole thing that we're trying to do, but what's the first step in that? Go ahead, Mia. Okay, so x equals 4y minus, or x equals 4y, you said minus 5? Okay, that's right. X equals 4y plus 5. But can anybody explain to me what she did? Rewrote the equation, but what changed? All right, so the step number 1 to finding the inverse of an equation is flip x and y. Okay, you just change their locations. And only the x and the y. Nothing goes with it. Nothing goes with it. Okay? Step number 2. And again, it's such an easy thing that you might not even think it's a step. Okay? But does anybody know what step number 2 is? Okay. Solve for y. Flip x and y, solve for y. What you're left with is the inverse equation. Okay? So we should already know at this point that x equals 4y plus 5. Now I want to solve for y. What do I do? Okay, subtract 5 from both sides. That's going to give me x minus 5 equals 4y. Now what? Divide everything by 4. So my final answer is y equals x minus 5 all over 4. You could rewrite that and you could say y equals 1/4 x minus 5/4. That would be fine. But I think that they're pretty satisfied with that right there. Okay? Let's see. Jacob, you left before I got to ask you, did you have your 61 and 62 notes done? Okay, you get a chance. Show me those. I'm going to erase some things up here. Okay. All right, 17. 17 should be pretty easy. Do we need to cover it? Don't need to cover it. Does anybody want to cover it? Yes? Okay. So when I say it's pretty easy, what I mean is everywhere where you see x, you're going to substitute in the number 4. Okay? Preferably with a set of parentheses. So 4 cubed minus 4 times 4 squared plus 2 times 4 minus 9. Is that easier than maybe what some of you made it out to be? Did you find those? Still looking. Okay. All right, 4 cubed. 4 squared is 16. 16 times 4 is 64. Okay. Now, 4 squared times 4 is the same as 4 cubed, right? So wouldn't that just be minus 64? And 2 times 4 is 8. Okay, so 64's cancel out. I'm left with 8 minus 9. 8 minus 9 is negative 1. Okay, looks like a hard question. It comes down to a really simple solution. Okay, so that's 17. Okay. The oven temperature for making baked goods at elevations over 3,500 feet should be about 25 degrees Fahrenheit higher than the temperature used at sea level. Okay? Write a composite function to represent the oven temperatures at elevations over 3,500 feet in Celsius. The conversion for Fahrenheit as is Celsius temperature is 5/9 the temperature minus 32, where T is the temperature in degrees Fahrenheit. Now, so you see that negative 32? Now, our temperatures, because we're above 3,500 degrees, have to increase 25 degrees, right? So all you really have to do is take negative 32 and add 25. What is that? Or 25 minus 32, what is it? Negative 7? Okay, so we're going to substitute, instead of negative 32, we're going to put minus 7 there. So you should get 5/9 t minus 7. Is that a lot simpler than it looked? Okay, does it make sense? We understand what we're doing there? Okay. $19. Let's see. I want to come back to 19. Let's go on to 20 for now. 19, I believe I'm going to end up making a bonus question if we see it, because it's a lot. Okay, LaDonna cannot remember the correct order of the 6 digits in her ID number. Okay, 6 digits. She does remember that the ID number contains the digits 107395. What is the probability that the first 5 digits of LaDonna's ID number will be odd numbers? The first 5 digits. Okay? So 1, 2, 3, 4, 5. Now, okay? Now it says, what is the probability? So it's number desired over number total. Okay? Now, I would circle odd numbers. So we got 1, 7, 3, 9, and 5, right? 0 is not an odd number. 0 is an even. Okay? All right, so probability, number desired over number total, right? How many odd numbers are there? 5. How many total are there? 6. Okay? Now we move on to the next one. Say we got an odd. How many odds are left? How many total? Okay, and we should see it go like that. Okay? Or 5 factorial over 6 factorial, essentially. Okay? Now let's see if that works. Okay, 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120, 120 times 1 is 120. Okay, so we got 120, 6 times 5 is 30, 30 times 4 is what, 120? 120 times 3? Oh, I don't know. What is it? 720? Is the total? 120 over 720? Okay, or 12 over 72, or 6 over 36. 6 over 36, it would be 3 over 18. Or what, 1/6? Does it come down to 1/6? Is 1/6 the correct answer? Yes! Awesome. Okay? Okay. All right. Okay, let's look at 19. I'm not making any guarantees here. Hopefully I can help you out. A shop makes tables and chairs. Each table takes 8 hours to assemble and 2 hours to finish. Each chair takes 3 hours to assemble, 1 hour to finish. The assemblers can work for at most 200 hours each week, and the finishers can work for at most 60 hours each week. So an assembler is somebody who's like putting all the pieces of wood together. A finisher might be somebody who's coming along and staining those things, right? Okay. The shop wants to make as many tables and chairs as possible. We want to write the constraints of the problem. Then we want to graph that feasible region. We want to let T be the numbers of tables, C be the numbers of chairs. If you guys have this, what I'm going to do is I'm going to pull up another page for us to kind of look at. Okay. Let's see. Give me, somebody read the first sentence again. Okay, all right. So each table takes 8 hours, right? 8T. Okay, and each chair takes how much? 3 hours? Okay, so assembly time. Okay? simply is 8t plus 3c if we're making, okay, a table and a chair, right? Okay, what's the next sentence? Or keep going with that sentence if there's more. Hold on, did I get something wrong then? Is it, okay. Okay, so assemblers can work at most 200 hours. So they can work less than or equal to 200 hours. Okay? Finishers? Okay, so they can work less than or equal to 60 hours. Okay? Okay, keep going. Okay, they want to make as many tables and chairs as possible. I feel like there's still more information here, isn't there? Did I miss anything? Table takes 8 hours, chair takes 3. Assemblers can work at most 200 hours. Finishers can work at most 60 hours. Okay. Does it say? Oh. So this is how long it takes to assemble. Okay, but to finish, okay, you said it takes 2 hours per table and 1 hour per chair. Okay. So to finish is 2t plus c. Okay? All right. Yeah, so you're right. So it looks like 8t plus 3c is going to have to be less than or equal to 200. And this is going to have to be less than or equal to 60. Okay? Okay. So what I would do with each of these is find out what my x and y constraints are, or what my x and y intercepts are. So let's treat t as an x and let's treat c as y. Can we do that? Okay. So if I want to know what the y-intercept is, I'm going to plug in 0 for x. And if I want to know what the x-intercept is, I'm going to plug in 0 for y. So the y-intercept, I'm plugging in 0 for x, so that's t. So it's 200 divided by 3. What's 200 divided by 3? Okay, so 66 and 2/3. Okay, now we're going to do the same thing. We're going to plug in 0 for c or y. What's 200 divided by 8? 25. Okay. All right, we're going to do the same thing down here. We've got our 0 here, a 0 here. Let's plug in 0 for t. So really it's just 60, right? Okay. And do the opposite. So it would be 30. Okay. Now hopefully I haven't missed anything. I feel like there's an obvious thing that's left. Obviously we can't make, like, we have to make more than 0, or we have to make at least 0. Like you can't make negative chairs or negative tables, right? Okay, so we know what quadrant we're in. Okay, we have to be in our first quadrant. Okay, and all of this is being run up in hours. Okay, so we have our, okay, all right. So if we're talking about assembly, our y-intercept is something like 66 2/3 and 25. Okay, let's say 25. And it's got to be less than or equal to that. Okay? So it's going to come back this way. Okay, the other one is just less than that because it has a a y-intercept of 66 and just past this at 30. So 60 and 30 is going to come out like that. You with me so far? And it's less than this. So it's coming down here. So our feasible region here and down here. Usually these things come out to, that point right there. So we'd have to find out where those two lines cross at. So anyway, you can understand why this is probably going to be a bonus question if it winds up on your test. Correct? So, do we want to stop here? Okay. It is going to ask for the number of tables and chairs. So if you can find the point of intersection, okay, they want to make as many as possible. 40 and 23.5. What was the answer, key answer? Right. Right. So t is still greater than or equal to 0. C is greater than or equal to 0. Right. They showed all that, but they didn't give you any other kind of answer. Okay, just asked you to graph, which we have pretty much done, haven't we? Yep. So, you guys do understand that t has to be greater than or equal to 0 because we can make 0 tables, but we can't make less than that. And chairs is the same way. Okay, so I think that gives you pretty much all the information you actually need in order to graph it. And if it's not asking for the answer, then you're in pretty good shape. Right? Okay. All right, we'll go ahead and stop there, and I'll try to get everything out to you.